confusing as well because this is not the exact syntax that we'd be using for an if statement. Usually we put if raining outside equal true. So let's go over into VS Code here really quickly. And we'll go into this guy, right? So normally, let's use the same example that we had on the board where we said raining outside. I forgot to mention this as well, but variables also need to be one word. There's some syntax to the variables in which you can't use certain words and you can't start certain variables with certain letters or symbols. So let's say raining outside is equal to true, right? So let me, if raining, that's not how you spell raining. If raining out is equal to true, then we say it's raining outside, okay? And this needs to be capitalized. So whenever you use true or false, it also needs to be capitalized. And then we're going to say else it's not raining outside, okay? So what this program is going to do, and this is how we normally would do our if statements, is we're going to say raining outside is equal to true, and it's going to run through and look at the first condition. And it's going to look at the variable that you assigned. Since the variable that you assigned is called raining out, and you set it to be true, then when it runs through and says it looks at if raining outside equal to true, then that condition is met. Do take note that whenever we're comparing in an if statement, we use the double equal sign. If you were to use the one equal sign, it doesn't know what that is because the singular equal sign is used to set something to the variable. So if I say x is equal to 3, I use one equal sign, like so. Now I'm setting x to equal to 3. But if I want to check if x is equal to 3, I'll use the double and say x is equal to 3. All right, that's how we handle our our if statements. Now, alternatively, let's say that we don't want, so if statements are usually two branched, right? So it's either this the condition is true or the condition is false. But sometimes the condition is true or false, branches into two main branches, but sometimes we'll have more than just two branches. So if I say that, if I'm checking, for example, what the value of x is, I can say else if x is equal to 4, then print out it's 4. Else if again, let's say x is equal to 6, and print out x is equal to 6. So what I've done here is that I've given the condition of if multiple conditions to question. And so what will happen is that it will run through the first if statement. It'll find that it doesn't fit the conditions, and it'll move on to the second if statement, and then the third and the fourth, and then up all the way up until it gets to else. Once I get to else, I cannot then say else if. I can't do that because else if only works if there's an if statement above it. If I was to say else, that is the end of my if code. So else marks the end of the if statement. In between, if I have more than one condition to fulfill, I can do else if. Now, can someone tell me what would happen if I changed all these else ifs just to ifs? What happens if I do that? Sorry, say again, speak up. Exactly. It will check for each of these, and then the else will only work for the last if statement. So the else here is only bound with this if. It does not look for the other if statements. Alternatively, when we did else if like this, then this else, this else right here, it was bound to every if statement before it. All right, that was a quick review on ifs. It's the same thing we did, else if, and the equal sign we also talked about. All right, so quick question here. These are the top pack questions. Arib, do we have that? It's on here. All right, cool. All right, so please head over to Top Hat. You can please head over to Top Hat. All right. Do I click present? Okay, so please join this code on the screen. You want to join the Top Hat? Yes. Oh, you guys don't have Wi-Fi. Yeah, they need to be UFC students. You want to do this the old-fashioned one, where like someone puts up their hand and we write their names down, so we can give them, because these guys are for sure with 9 points. Is there a guest Wi-Fi? Log into the guest Wi-Fi. It's not working. It's not working. Is it working? It's not working for everyone, or just? If it still doesn't work, you can log into the computers in front of you, actually. While you guys are waiting, I'm gonna start this guy. These are not timed, right? Why is it? Why is it? Why is this time? Oh, why is it time? So we're just waiting on everyone to be able to join the Top Hat, and then we'll start it. Yes. Yeah, I haven't presented it yet. Yes, someone raised their hand. What's up?
I'm just wondering, on the Top Hat, are we supposed to see the slides you're currently presenting,
Sorry, let
or
me go back into
because I have it up and
you
it's
can
not
pass it back,
showing
that's
or
all.
anything?
Oh, okay. Someone raised their hand. What's wrong?
Oh yeah, in the Top Hat, are we supposed to be able to see those slides that you just had popped up yet, or are they not like assigned or something?
I can't hear. I think Sebastian is talking, but I can't hear you.
Oh, you can't hear me? Can you hear me now? Test.
Okay. Okay. What's the code for the Top Hat? Huh? The code for the Top Hat. Yeah, it's right there. One second. No, because like, why is it timed when the questions and slides? Yeah. But it's in the slides. Alright. How is everyone online doing? Code is working. Students are now able to see the questions at the moment. That's cool. If you can see it, go ahead and solve it. But on my end, at least, I know you guys can see my screen, so I haven't started the presentation yet, so it's a little weird, but it's okay. Okay, so is everyone good? Everyone ready? Yes. Like attendance wise? Yeah, we do attendance at the end of the class. How's your attendance block now? Yeah. Supposed to cover like 63 slides. Oh, yeah. Oh my God. Okay. We're just going to start. Aside from whether or not everyone is able to get in, it's okay. Just go ahead and start. All right. So what is the correct? The question isn't even viewed. The question isn't even viewed here, man. Okay, here's what I'm gonna do. Yeet. I'm gonna do this. We're going to do this. The top that they can see on the top hat. They can't see the question. Can you guys see the question on the top hat? Yeah. You can see the full question, like with the code. No, not the code. Yeah, so they can't see the code. It's not saying tap only the slider. Okay, go ahead and answer this on top hat. Am I doing math today? I'm doing math today. There's no way. There's no way, dude.
Oh, no, no, okay, that's fine. No, no, that's fine. Okay. We're good. Oh, so. Now you
Okay.
just go to responses. I don't know.
All right, so responses, we got 6 for C and 5 for D. I'm good. Listen, it's C, it's not D. It's if statements, not else if statements. It's if statements.
Yeah, so it should be D. Because it'll print both the second and the third.
Oh yeah, you're right. So yes, okay. Should we go over the? Yeah, there's no people that answered it incorrectly.
Not right now. They are quick questions. The slides.
Okay, I'll just clear up really quickly. Okay, so we're gonna go back to lecture. Okay, so for those people who said that the answer was less than 20, I can see why you said that. I understand it might be a little bit confusing. Actually, I almost made the same mistake. So the reason that the answer is less than 20 but greater than 0 is because when you actually get the result, the number is 14. And all of these condition statements are if statements, not else if statements, which means that it will run through every single one of them. Had it been else if statements, then once it found the correct one, it will skip right away to the end. It will end it. Okay. So the difference between the two is that the if statement, the difference between the two is that the if statement will run through the if statement first, will run through the first if statement and check it. And whether it's true or not, it will run to the next if statement. Now, if it was else if, then it will run through the first one. And if it happened to be true, it won't run the else if statements. It will skip to the end right away. All right. All right, so lists and we're doing tuples later, but all you need to know for now is that tuples are lists that can be changed. Okay, so what are lists? Like I said before, variables are used in order to assign a callable value to something. And lists are exactly that. They are an array of numbers that start with the index 0. And in order to access each element, we call the name of the variable, which in this case would be numbers, and we also call the index that we want. And so let's say that over here, let's say that we have a list. Let's call it my list. And we're going to create a list of, let's just do till 5. All right. Now, if I want to get the access to number, actually, that might be a little bit confusing. Let's do this. Actually, that's not. Let's say I want to print out the number 1 from this list. What I would do is I would go say print my list at 0. Okay. And what this would do is that it will print out the first element of the list, which is 1. Now, in most scenarios, when you create a list, you actually want to be able to iterate through the whole list. And we'll go over that briefly by going over what for loops are. Okay. All right. So Copilot is just doing things today. Let me turn it off. Okay. So in order to iterate through a list, we have to first create an integer, I. I is what's usually used in order to iterate through lists. And we're going to call the name of our list. Whoops. Okay. So what I've done here is that I've created a loop. And this is advanced class, so I'm assuming you guys know what a loop is. But what I've done here is I've created a loop and used the integer I in order to iterate through my loop. So what I actually does, we can see here. Ooh. So what I hold the value of the index. So we said before that when we want to get an access to a specific element, we would call it like this, right? And so the index of 0 is the first element of the list. So this is index 0, index 1, index 2, index 3, index 4. And for me to access the first one, I need index 0. Now, if I want to access every single element inside this list, what I'm going to do is that I'm going to create a loop and have I be my index. And so for the index inside my list,
Python for
no, I don't see it. Am I mixing it with Java? Oh, you're right. Whoops. There we go. My bad. You're right. Okay. So so it's all internal. That's cool. So for I in my list, I is going to be the elements inside the list. How can I? One sec. Okay. So what for I in my list does is basically it runs through every index inside my list and assigns the value inside that index to the variable I. If I was to run this at only like for one iteration, let's create a stop point here. Okay, so this is its first iteration after I've stopped it. So we can see on the side here that I holds the value of the first index, which is 1. This variable here can be anything. I can say numbers instead. So for numbers inside my list, print the numbers. And this automatically goes through. In most other languages, you need to define the range of the list or how many elements are inside the list or all that stuff. All you would need here is just to say that for numbers inside my list, print out the numbers. All right. Let's stop this debug. Here's the list of the stuff that we can do with lists. And you'll notice here that we're using something called the dot operator. All right, and we'll go over what the dot operator does in a bit, but so we can see here that we can find the length of the list using length of the list. All these slides are on the website. You guys can access them, or you can just search up. And you'll find most of the function calls that we can do with lists. Okay. Yeah, it is. Okay, we already went over loops. While is the same as a for loop. The exception is that it requires a counter manually to be iterated. Okay, so you'll notice here that we didn't have anything to iterate through the list. It automatically did it. So when I said 4 numbers in my list, it automatically knew that it needs to iterate and add 1 onto the index every single time. So the first run gave us 1, and then the second run gave us 2, 3, 4, and so on and so forth. By the way, if anyone's confused why there's 2 1s here, it's because there's a print line here for the first index. So if I do this and just run it, there we go. Okay. A while loop would be the same. Let's do is less than. Ooh. Okay. So print. Okay, so we can see the difference between the two loops right here. When we use the for loop, there was no need for us to introduce the variable numbers or assign it value. And we didn't need to iterate through numbers either. It automatically knew that through the first iteration, numbers is going to print out the first number, and then the second iteration will move on to number after that. Now, in a while loop, it does basically the same function of a for loop, except that there's some extra steps that you need to put in order to achieve the while loop the way you want it to. First thing you need to do is that you need to introduce a counter. Okay, so we're gonna actually call I here the counter. All right. Should just replace all. Okay, so first thing we need to do is introduce our counter and then give our conditional, which is as long as the counter is inside the length of the list. Okay, so can someone tell me what the length of this list is? What's the length of the list? How many elements are in this list? 5, right? So this number right here, this value right here holds 5. Okay. Can anyone tell me why these guys are different? You can look at the slides. It's there. Am I actually iterating through any list here? No, I'm not. Over here, I gave it the condition of my list. So it knew that numbers are going to be inside the list. Okay, cool. It's inside the list. Awesome. When I went over here, it saw counter. Counter is equal to 0. Okay. Now, while counter is less than the length of the list. What's the length of the list? Well, that's equal to 5, which means I could have literally just said this. And it would be the exact same. Just because I called the length of the list doesn't mean that it knows that I need to iterate through this list. I simply just gave it a number, a type of integer, in order to look at it. Okay? Does that make sense? Awesome. If I wanted to make it the same, I'll introduce my list here. There we go. Which, if you notice, that's the mistake I did in the for loop above it. When you use a while loop, you have to use the index method. All right, so the counter is going to be your index. It's going to look at this guy. All right, so while counter is less than 5, cool. So the maximum counter can get to is 5. So print the list at the index of the counter. So the first iteration counter is 0. I'll run through. Okay, counter is 0. That's 1. It's going to print out 1. And then I'm going to add 1 to the counter, and so on and so forth. Any questions about that? Awesome. Okay. Question 2 on top hat. Ooh. Top hat's starting to give me PTSD. Yeah. Okay, so go ahead and answer that. There we go. Just the question there. If anyone's still working this, sorry, but I'm going to try to clock out. Okay, one person still hasn't answered. All right. Okay. Majority of people said 3, which is correct. It's great. That's an excellent question. I'm not really sure. Yeah, but I don't see if I move it. Okay. All right. So, oh, I can't move. Okay, I stay here. So why is it 3? We have a list here, and the list is holding a bunch of strings. Strings is what we call words, right? So it's holding a bunch of words, okay? And then you have a for loop. This for loop is iterating through the elements of the list. So your list here is the traffic lights, and the light is the element, okay? So the first element in this list is red. So the light at 0 is equal to red. Awesome. So the first iteration will run through list at 0. It's going to look if the light is red. It sees that it's red, and so it'll print waiting once. And since there's no else if, it's going to jump right away outside of that for loop and then go back to the beginning of it doesn't jump outside, it jumps back to the beginning of the for loop to check the condition again, and sees that light still has more elements inside the traffic lights. And so it'll run to the second index, check if it's red, and so on and so forth, right up until it reaches the last one. It sees that the last one is green, it's going to go to the else statement, and then it's going to print go. It's going to go back to check for the condition, which is for light in traffic lights. And it's going to notice that it's reached the end of the traffic lights, and so there are no more lights inside the traffic light. That is to say, there are no more elements inside the list. You've already iterated through every element inside the list, and so you're done with that. And so it's going to stop the for loop. You don't want to get stuck inside an infinite loop. It's ugly. So you always got to be careful with your indexes. And it prints 3 times here because you have 3 elements that are red. All right, functions. So, okay. I'm sure many of you guys have actually heard the word object-oriented programming like 100 times before. But very few people actually know why it's called object-oriented programming. And in order to know what that is, first we have to look at what an object is in the terms of coding. Object is like an umbrella term that we use in order to define functions, okay? So when you're using Python, an object is a function. When you're using Java, an object is a method. In C++, it's a different thing. In HTML, well, actually, I don't think there's JavaScript. In JavaScript, there are. The point is, functions are what we call objects. Object-oriented programming revolve around the functions. And in order to have a good function, you need a simple function. The best function is the simplest function. The more arguments or the more you have a function do something, the less powerful the function becomes. And the more time-consuming it becomes. And so you always want to aim to simplify your code using these functions. I gave this example last time, and I'll give it again. If I was to build a code to get the time of the day, then I would create a function to get the day I would create another function to get the time, which is the hours, and another one to get the minutes, and another function to get the seconds. All these functions join together to create our code. And that's why we call it object-oriented programming, because you have all these functions, or if you want to use the umbrella term, objects, you have all these objects combining together to create your program. And hence why it's called object-oriented programming. And this is the same programming language and like method that you'll see anywhere. And the reason we use it everywhere is because it's very, very powerful. When you use functions, then something goes wrong, you don't need to fix your entire code. You only need to fix a certain block of your code, which is a lot easier to do. Okay. So here's the syntax in order to use a function. That was a little too far. Okay, so in any function, no matter what it is, you always define it as def. Okay, the first word you're going to use is def. So let's say I want to create a function. Okay, I'm going to make a function that adds x and y. Okay, so I'm going to call it def sum, and I'm not going to have it pass any arguments inside. Okay, I'll go over what arguments are in a second. Oh my God, GitHub need to relax. I mean Copilot. Okay. So I'm going to say x is equal to 2, y is equal to 3, and sum is equal to 2 plus 3. Okay. And we're going to leave that for a second because I want to come back to it. All right. So I want you guys to take a look at the syntax of the function. All right. We have def, which we have in the other one as well. And then the name, this name is up to you, the programmer. You can choose whatever name that you want. Right? Most commonly, you'll find foo as the name of the function. Okay, so don't name your function foo. Normally, you want to name your function something that tells you what it does. So, for example, over here, when I wanted to create a sum, what did I call my function? I called it sum. You always want to use good naming in order so that if you leave and you come back, you know what this variable is without you having to run through your code. It becomes terrible when you have over 1,000 lines of code and you're looking at a function and the function is named foo. I don't know what foo is. I don't know what it does. Now I have to run through the code, which is a problem. So always use names that tell you what the function does. Okay. Oops, not you. Okay, and you have the function body. Also, don't forget your semicolon. Usually, I'm assuming everyone here has VS Code. So usually it'll just show you like a red line underneath it and it'll tell you that you did semicolon. So it'll help you with the syntax there. But don't forget your semicolon. This is a colon or semicolon? It's a colon? English is great. Anyways, yeah. So sorry, colon, not semicolon. And then you're going to write your function, whatever you want this program to do or be right there. It can just be a print line. It can be a simple summation. It can be a call to another function, which is a disgusting thing to do, but it's all right. And then this right here is very, very important. The reason we create functions is to get something back from it. So it's like sending someone on an errand. If I was tell Arif to go grab water or something, that means that when I call and say Arif, go grab water, when he comes back, I need him to come back with water. That's why I'm calling him. So when we go over here, and there's a reason I left it like this, if I was to run this right now, this function is absolutely and unequivocally useless. Why? It never returned with anything. I'm going to call it in my main, so I'm going to create a main function here. I'm going to print it actually. Okay. And this atrocity. Don't worry about what this is. It's fine. I think it was this. That syntax is wrong. I know it is. That's fine. I'll go over what the if thing does there. All right. So I called main. Main is what you're automatically running main. Okay. So the main function is going to call sum. It's going to go over a sum. It's going to do this calculation, and then it's going to stop. It's going to come back to main with absolutely nothing in its hand. It's going to be completely empty-handed. And all I've done is take up memory and space and time. which we don't want. So always, 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 always return a sum, okay? Or return something. If you don't want to return anything and it's just a print line for whatever reason, I don't recommend you guys do functions for print lines, but you can also return print lines. That's okay. You can return print lines. You can return anything, just return something. If you have nothing to return, don't ever use this, but you can just return void or null. Do you have null here? I think it's just 0. None. Yeah, none. Null is Java. You can return none, which returns nothing, which is useless. Don't use it, but that's not the point. So always, always, always return something from your function. Make it useful. Okay. Function example, I already showed you guys that. And calling the function right here. This is how you call a function. Okay. Actually, if I'm returning something, then I don't need to do the print. You can just say sum. There we go. Okay. That's me calling my function. This right here, this line right here, it lets the processor know that it needs to go and look for a function called sum. It's going to have 0 arguments. Now, let's say that I want to give it some arguments. Let's say it's A and B. So what this function here is going to do, what I'm planning to have it do, is going to add A and B together. Cool. So over here, this right now has no idea where to go. None. Because when I went and created my function, I created it with 2 arguments. And over here, I'm providing it with none. So I can do 2 and 3. Now it knows. Now it has the same number of arguments as the actual function. And so it knows that that's the function it needs to go to. Okay. We're going to return the sum. There we go. I want to print it. And hold on 1 second. There we go. Okay, there we go. Returned our sum, completely fine. Awesome. We can move on. Any questions about that? Cool. Question 3 on top hat. Okay, I just feel like someone's AFK. Somebody. Can I end this? Okay. Ah, I know there's. Okay. There's a variety of answers here. Okay. So the reason this function is wrong. First off, I want to address the equal sign. Right here, we're setting something to be something else. So we're setting the return value to be a plus b plus c. So we don't need to use the double equal sign. We only need to use one. So that line is correct. Actually, every line in here is correct. The problem is that it's missing something. I never returned anything from this function. This function is, as I would call it, absolutely useless. It doesn't tell the main function, or the value rather, what the return value is. So you're returning nothing. By the way, you can return multiple things. Okay. So the problem here is that we're not returning anything. Okay. This might not, you guys might not know what that is, but that's shorthand for basically return value is equal to return value times 2. That's all it does. Okay. Cool. I'm going to start zooming through these since we have our building blocks now. Tuples, lists that can be changed. That's all it is. Normally when we do a list, we can go back and access its element and change it. So I can say the list at 0 really quickly here. I can say my list at 0 is equal to 6 now. Can do that. And so now when I print it, my first element is now 6. I just overwritten the first element. Cool. Now, if I was to do that with tuples, if I make this into a tuple, I can't change it. And you can see that in the slide over here, right? Right here, they created a tuple, and notice that a tuple has round brackets, not square brackets. Lists have square brackets. Tuples have round brackets. Dictionaries have swirly brackets. We'll get into that later. But they try to print the tuple at 0, which is fine. You can access the elements. But the second you try and change an element, it gives you an error. You can't change the element. And that's good. That's what we want in Pygame, because you don't want someone to change the coordinates of something that doesn't need to be changed. Okay. Right. Okay. Let's see how much dot operator. I'm going to come back to this after going through the dot operator. Okay, the dot operator, all it does is it calls a built-in function inside Python. Something like the length of the list is a built-in function. The dot operator does that, but in a different way. Some built-in functions can be called using the dot operator, and some others can be called using the round bracket, which you can see right here. So the length is a built-in function in Python, but it's called using the round brackets. And then append is used the dot brackets. I mean the dot operator. Okay. And you can chain your dot operators. Okay. So if you have one dot operator, you can chain it. I'm not going to get too much into this, but basically in order to chain it, you need to create a class and then have multiple functions and call it all. I remember there was an example that I had somewhere here. Nope. I don't have it anymore. That's okay. You guys don't need to worry about that right now. Okay. Just know that you can chain them if you wish. Okay. All that's left now is the Pygame. So this is the exercise now. Let's do the exercise right now. This is your exercise. Okay. Open up VS Code and write code to find and print the smallest x coordinate in the list of coordinates below. Okay. So take this list of coordinates right here and find and print the smallest x coordinate, which is the first one of those parentheses. It goes x, y. Hope you guys know that. I pray you guys know that. If anyone has any problems running or opening VS Code, feel free to speak up now. If you have a problem on how to approach this, speak up now. Okay, I'm gonna stop sharing for just a second here. Okay, 5 minutes are up. How are we feeling about the exercise? If it's in the middle, then good. Because me lecturing does not equate to you knowing how to solve a problem using code. Okay. The only way to learn how to code is to actually code. Cool. So if you feel meh about that, that's totally fine. The more you solve, the better you get. It's like math, but worse. Okay. So the solution. Here it is. Okay, first let me just do this. Okay. So we introduce our list. We introduce your minimum can be anything, by the way. Like this is a temporary value. Okay, you can change this to 0 and it would work the exact same. All right. Okay. Actually, if you change it to 0, you're just gonna have to change this if statement down here. But let's say that it's 9,099. Okay. All right. So we're gonna create a for loop. We're going to iterate through the list. Okay. So first off, it might be seeming a little bit confusing because you have a list. It's like a tuple inside the list, which might be seeming weird, but you can act as if it's a list and it will do the exact same function. The reason you can do that is because it's a tuple, which means you can't change the values in here. Okay, so you create a for loop. I don't like the fact that they're using the word coordinate here because it's very similar to coordinates, which is the name of your list, but I digress. So your coordinate is going to be your elements. So you're going to iterate through the elements inside this list, and you're going to check each coordinate if the coordinate at 0. Okay. So here's the important part. Since we're looking at a tuple inside of a list, we're going to need to iterate through it twice, right? So the first for loop right here, we iterated through the list. So my first element inside, just by using the for loop alone, is going to be the first tuple, the first parentheses. It's going to be 22 and 0 and 10. All right. So let's debug this so you guys can see it. And let's put a breakpoint right here. Okay. And let's debug. Okay. So let's make this a little bit bigger. The coordinate right now, this is the first element. This right here, that's the first element inside the coordinates. And all I've done so far is run through this singular line. This one. I haven't reached this line yet. Okay. And once you see that, you find that it's actually really easy to do the rest. Because all you have is a tuple with 2 values in it. Which means when I come to the next line right over here, all I need to do is tell it, look, this coordinate right here that I have, this tuple, I want the first element, which is your x value. So I'm going to compare the coordinate at 0 with the minimum x, which is 9,999. Again, it depends on what temporary value you used. If you had used 0, then you would need to change your if statement to match that. But since this is 9,999, all you're going to do is going to say, look, if this x is less than that minimum in the first one, I'm going to set it to be that. Does that make sense? So my minimum is going to be equal to the coordinate at 0, which is your x value, which is this right here. It's going to equal to 22 if it's less than the minimum value that I set before right over here. And since it is, then it's going to be equal to each other. So now my new minimum value, if I was to put a break line right here, my new minimum value is 22. All good. So I've done that with the first one. And since I already initiated the for loop, I don't need to do anything else. Because when I press enter, it's going to run through the loop again, and now it's going to ignore this guy. And it's going to look at this guy. Okay? So again, step into it. Now my coordinates change to the next element of the list. And I'm going to check if it's less than. I see that it's not less than. So this if statement doesn't do anything. It's going to keep running. It's going. Notice how it went right back to the for loop. It went right back to the for loop because the condition did not satisfy, and so on and so forth. And it keeps going and doing this until it reaches the end of the list and realizes I'm done at this list and I found my minimum, which is going to be your 18. All right. Let's stop this guy. Okay, so these are all basically the building blocks that we're going to use in order to look at Pygame. All right. I'm gonna have to zoom through this because I'm supposed to give you guys time to actually do the exercise, which I totally did not do. Okay, Pygame. First off, let's. Did we go through the installation of Pygame last time? We did, right? I'm pretty sure we did. Yeah. Okay. So all of you should have Pygame in your terminal right now. I think it's yeah, it's the wrong one. It should be in command file. Okay, that doesn't matter. Pip show Pygame. Yeah, so this is how you guys can check if you have Pygame or not. All you need to do is go into your command prompt right here. You can go also in command prompt from over here. That works too, I guess. Command prompt. Okay, and just run pip show Pygame. And if that pops up like this, then you're good to go. Okay. So in using Pygame, we have three main sections. We have our setup section. We have our events section and our update section. Oh, and the draw section. Sorry, four sections. Okay. So you have your setup, your update, your events, and your draw. The only one that I think needs clarification is the event. The event is basically like if you quit outside the gate. Like anytime you press a button or you press X or minimize or whatever, that's your event. That's an event happening inside the game. Okay. Setup, obviously set up the window and the game and stuff like that. The update is if you need to move something inside your Pygame, and the draw is to, well, get them to go to life. Okay. So let's take a look at our setup. Before we do anything, we have to initiate that what we're about to use is Pygames. So we have to import Pygames library. Okay. Very simple. You don't have to worry about these guys right here for now. Do they have access to GitHub, right? I'm pretty sure, yeah. So if you guys go into the GitHub that we provided for you guys, it should be on the slides as well, right here. Yep. If you guys look at this right here, this GitHub has this file and all subsequent files as well. I'll go over how to clone the GitHub repository next time in case you need it. Okay, so the first thing you have to do is initiate the Pygame module, which is the next line right over there. Pygame.init, little bracket. Okay, and that's calling a function init. Okay, so now that I've created okay. I'm hoping that doesn't die. Okay, that's pretty slow. Sorry, one second. Gotta plug in my cinder block real quick. Did you guys see this? Cinder block. All right. Okay, so once I've initiated what Pygame that I'm going to be using Pygame, my next step is to create the dimensions for my screen. Okay. Don't be worried about the name of the variables because it can be any name that you want, but just choose a name that lets you know that this is what you're going to be using. All right, so I'm going to set my width to 1000, my height to 800, and the frame rate to 60. If I happen to not like this, I can change it freely. Don't change this file. If you're going to use GitHub, don't change the main file. There's a file right here called copy and rename. You can Control C, Control V, and you're going to create one just like it, and you can rename it whatever you want. I already renamed one temp. I'm going to name this one temp 2 because I'm super creative. Okay, and I'm going to run it. This is the game that it gives me. Okay. If I want to change this guy, I don't like the width, for example, I can change it to 900, and I can change this guy to 600. And as you can see, my window size got smaller. Okay. All right. So these are just variables so far. We haven't done anything with them. These are useful variables that we're going to use. So the color, we use RGB colors in Pygame, which means it's 3 coordinate colors. You can search these up if you want, like blue, for example. Just write blue RGB. They give you the colors. These are some useful ones: black and yellow. Black and white. And here is our function in order to set up the window and use those variables that we wanted. So we're going to say screen or window or whatever I want it to be, right? Window is equal to the Pygame dot display dot set mode. This is the chaining that we were talking about. Okay, you don't need to know what this actually does or anything like that, but this is the way you do it. Okay, so we call the Pygame module, we call the display module inside the Pygame, and we finally set the mode into the width screen and with height and screen height. And the reason we do this is, again, because we don't want to hard code anything. So whenever I want to, I can just go ahead and change these numbers and it automatically changes here. Okay. We also create a clock. This setup right here, this setup you guys can use every single time. Just copy paste it. You don't really need to know too much what it does. It's fairly simple though. I just told you what it did. You don't need to remember every single time. Just copy and paste it. Okay. Now, while true. So while true basically means the default condition on any while is always that it's going to be true. So unless specified that it's false, it's going to be true. And so when the code reaches this line, it's going to be like, all right, well, it's always true, so we're good to go. I never set it to false, so it's good to go, and it's going to keep going. Okay. I don't think they do here, which is weird, but yeah, like you can do this as well. Okay, so run while true. So here I've manually set it to be true. And I said while run. This would be the exact same thing if I just said while true. Okay, and so for the event that someone presses quit, I can just turn it to false. So if I run this, if it can run, that'd be great. There we go. There it is. Okay, this is my game I have so far. And then when I press X, so when I press X, that's the event that occurs. I'm going to press X, and it's going to set run equal false. I'm going to be able to put it just fine. Okay. Okay. So again, we're going to call another function from Pygame, which is whenever you click on something on the keyboard, you click something on the keyboard, and we're going to call it keys pressed. Okay. All right. And it's going to be a type of bool, which means basically that it's a Boolean, which basically means it's either true or false. That's all it can be. Okay. So if keys pressed, right. So this right here is basically saying if I press the up button, the left button, the right button, or the down button, what is going to happen? I can replace these lines with whatever I want. Okay. I haven't decided what the game is going to be yet in my mind. So I'm gonna keep these as passes for now. But normally I'm just going to give you guys what it looks like when you want to condition something for an if statement whenever you play the game. So normally when you play a game and you press the left button, for example, then your character moves to the left, or the right. When you press the right, it moves to the right. And that code would go in there. Okay. All right. So normally when you're creating a game, you need to get the position of the character. Oh my God, I have 2 minutes left. Okay. You need to get the position of your character. And again, this is why everyone loves Pygame, is because it has everything already built in. That you don't need to create a function to get the position. It's really complicated. All you need to do is just say, hey, pygame.mouse.get position. And that gets the position of your character. Okay, and it gets the position in a coordinate x, y coordinates. Okay. Most of these guys you can search up fairly easily, in the sense that you don't need to memorize. Okay, I need to say pygame.mouse.get pos, get pos, and then brackets. You don't need to memorize that. That's what you need to do in order to get the mouse position. You can just go into a new tab and write mouse position. Sorry, just write position. Okay. That's not their own. I'm just going to this guy. Yeah. Okay. So you're going to have all of these different functions right here, and they'll tell you what it does underneath it. Right. And also you're going to have access to this guy at all times. So you can also come in here and take a look. Okay. Comments are there. All right. So now mouse buttons. When I click my mouse instead of my keys, I want to also do the same thing. So again, I'll tell Pygame to hey pygame.mouse.get pressed. Okay. So instead of getting the position of the mouse, I'm getting the pressing of the mouse. Okay. And again, I'm going to just pass it right along here. So at 0 is left mouse, and at 2 is right mouse. At 1, it's your scroll wheel, and so on and so forth. If you have more buttons on your mouse, I don't know what to tell you. I don't think it works with like that, but if I'm wrong, please tell me. Personally, I haven't really used it. Okay, so let's run this guy. Okay. Okay, so this is a non-interactive game in the sense that it's not going to ask you for any inputs because it doesn't really care about your inputs. All it's going to do is that it's going to go over here. This is everything that's new now, right? It's going to create a rectangle. It's going to call it rectangle. And it's going to go, hey, look, Pygame, create a rectangle for me. Again, you don't need to create a rectangle manually. You can just tell Pygame to do it. And that's why everybody loves Pygame. Your first variable is going to be, you can also hover over this, by the way, and you can take a look at what it does, right? So your first variable is going to be your left float, and then your top float, and then your width and your height. Usually your top and left float are 0 because we don't really care about that. And then your width and your height is going to define the width and the height of your rectangle. And it's going to set the speed of X and the speed of Y. These are just variables right now. They're not being used at the moment. And it's going to go into main events, right? So it's going to look, hey, look, I want to get the event. And if the event happens to be that you quit, which is that you press on the X button, it's going to pygame.quit system.exit. So it's going to exit outside the entirety of the system. And I'll go more in detail about this. Like I'll mention this briefly next time, since we're running out of time. Okay. Like I said before, all these guys are doing is that it's setting the X and the Y to be the rectangle speed at X plus the rectangle at X. Okay. I don't want to get into too much detail now. So I'm going to leave it. Okay, I'm going to stop it here for now. Yeah, you guys have access to all these slides. These are all the stuff that I said before, right? You have 4 sections. You have the main loop. This is your first, the first thing that you want to do. And you want to set a clock in order to control your frame. And then you're going to set up your screen width, same. And this is why we use tuples, by the way, because you don't want someone to mess around with your screen width and height. Yep, same thing. So events, update and draw. Update is when you want to change the position of the character, for example. That's when you update it. Or if you want to change the background screen to a different color, that's when you update it. Okay. Events is something that can happen anytime. Clicking, like I said. Update section is when you want to change a variable. Draw section is when you want to get them to come to life. So you're drawing it, you're filling the blanks, you're filling the background, whatever it is that you want to do. You don't need to know how to use these by now, like right now. But don't be scared that, oh, I don't know how to use any of these. You just need to know, like, okay, what they are. Okay. All right. So again, like I said, RGB, which are also tuples. That's why you don't want tuples to change, because you don't want someone to mess around with your colors. Okay. I might look at this next time, but like I said, the way you create a rectangle is pygame.rect. Creates your rectangle, and then you set its dimensions. Okay, so as you can see, the width and the height, and then here's your top and your left. Okay, and here's what RGB red looks like, by the way. Oh, yeah, that's what RGB stands for: red, green, and blue. Okay, so all these are stuff that we already went over. This is stuff we didn't go over. We'll go over that next time probably. And the exercise that you guys were supposed to have a bunch of time to do, well, clearly that's not going to happen. Because, you know what, let's blame it on technical difficulties, and yeah, total technical difficulties. Okay. You also have an exercise. Okay. Listen, like, I can keep going, but like, I mean, I keep going because we want, you know. Yeah. No. I mean, this is not graded, so it's not going to affect anything. But there's something called Ignite Points, and you guys get prizes for that at the end. Also, we kind of already gave you the code for it. Sorry, call. They have okay. Let me. I'm gonna go a little bit over time, but I'm just gonna show you how to get to the GitHub. Okay, you see this link, this lovely link. You're gonna take it. You're gonna copy it. And you're gonna paste it. And ta-da! You're at GitHub. All you're gonna do is you're gonna scroll up. See this lovely green button? You're going to press it. Normally, you would need like GitHub to clone it and then push it and pull it, but we're not going to do any of that. Ignore all of this. You're going to go right down to download zip file. You're going to click on it. It's going to download for you a lovely zip file. There it is. Okay, you're going to click on it. I hope you guys have RAR. You don't need to have it, but I hope you have it. By the way, zip RAR, it keeps telling you that you need to pay. You don't need to pay. You can keep using it. It's totally fine. You're going to just click this extract, and you're going to extract it somewhere. Press OK. Okay. And here it is. You're going to click on it. If you go into session 1, Pygame, your assignment. Ta-da! Any questions about that part? Cool. So this helps you with your assignment if you need it. Also, your assignments is basically on the slide as well. So if you get stuck there, your assignments are not like to grade you or anything. They're trying to help you out and get you to have hands-on experience in actual coding. Okay. So the rules and the details of what it is can be found here. That's the Ignite points. So the Ignite points. You guys are the Flare class right here. Any more questions? What? The attendance code for what? The what? The top hat. Oh, okay. Yeah, I'll give that to you once we're done.
Should also be on the slide.
It's also on the slides, yeah. Where can I find the slides? So slide shows of each session. Well, if you attended our first session. Let's see if I still have that guy. Wow, we actually remember it. Nice. Oi. Did I misspell Shulik? I misspelled Shulik, didn't I? Yeah, no, Shulik is like the best thing to spell out. There we go. Okay. There's your submit exercise, by the way. Just a quick FYI. Yeah. You guys are Flare. Okay. Scroll down. Session 1, session 0. You can view the slides right here. And those are the exact same slides that you guys have. Even has the review. It didn't seem like a review for you guys, but that's okay. Cool. Questions? I gave you guys my email last time. If you have any questions, feel free to ask there. Also on Discord, feel free to ask there as well. From there, not always there. Like you'll get a response in like minimum like a second if I have to be on there, but you might wait for like an hour or two for me to check Discord. Any other questions? All right. Have a good day. Thank you for coming. Zoom, you guys are all good? Lovely. Okay, let me stop sharing. All good on Zoom? Okay. See you guys next week, same time. Bye.